This particular video tutorial is in relation to Chapter 6, Exercise 6.6, Question 3. Now this particular question has got three parts, A, B and C, and this video tutorial will be dealing with Part A. Part A is in relation to a heat pump system, and there are four different components in a heat pump system. In this case we're given one, so we're told at location 1 we have the evaporator. The other critical piece of information we are told is the direction of flow of the refrigerant. Now at the evaporator, energy is being taken in from the external environment, and so it's a component that's taking energy in. The refrigerant passing through the evaporator will evaporate, turning from a liquid state into a gaseous state. Now that refrigerant is then pumped from location 1 towards location 2. Unfortunately, at location X, the refrigerant just before it enters component 2 is still at a relatively low temperature. So this gas must be increased in temperature somehow, and to do that we use the compressor. The compressor decreases the volume, and in decreasing the volume there is a corresponding increase in temperature, and now that gas is at a high enough temperature to be moved on to the next component, which is the condenser. The condenser really does the opposite of the evaporator, in that it takes energy from the refrigerant and it transfers it to the external environment, and so we're really taking energy out of the refrigerant. The refrigerant at this stage will start to decrease in temperature, and it will also lose energy, and it will start to convert back into a partial gaseous and liquid state, and this mixture of gas and liquid is transferred from location 3 to location 4. But before it enters location 4 at point Y, the mixture of gas and liquid is still at a very high temperature, and before it's pumped back to the evaporator again, that temperature must be reduced, and the component that it reduces the temperature in is the expansion valve. Now the refrigerant decreases substantially in temperature, converting back into a liquid, and now it can be pumped back to the evaporator and the entire process can continue.